Hello Pratham, am I audible?
Yes, pretty good, sir.
Hello Pratham, is it audible or not?
Yes, yes, sir.
Hello Pratham, am I audible?
Okay. So can you hear me? Hello.
Now I am audible. I think yes. Now you are audible to me. Okay, I have shared my screen. Let me know if it
No.
is visible.
Yes, yes.
Okay, so yesterday we completed, like we discussed this portion, the ring portion, and then we move to the discs. Okay, so have you solved this part?
No, I couldn't. I didn't have time.
You're not able to make it. Okay,
Yeah.
okay, fine. And what about the disc portion, the field due to the charge disk?
Nothing. I couldn't do anything.
All right, so let's make this as a part two then. So, adding the page. Let's use this. Mm, different. Yeah. All right, so first we should. I'll take the first question. What is that? Okay. So, what was the electric field due to the ring? That was KQX
Yes.
divided by what was that? X square plus R square. Is it?
Yes.
Okay. So I told you to get the maximum, like the value of x where you will be having a maximum electric field. Okay. So to get it, differentiate sheet with respect to x. Okay.
Yes.
In that case, you will be getting something. Yeah, dE by dx, and it will become what? This things is there. Let's remove it for a while and put it like simple manner. Okay. Now you have to differentiate this portion d of the whole x square plus r square 3 by 2 dx. Okay. This is what
Okay.
part you have to do. So can you differentiate this portion? Basically, this is what method you have to use. Differentiation of u by v method, where what this formula says is, any idea? Just take the u normal, put it like this, and differentiate this. Remember this part?
Yes.
Okay. So you wanna try to solve this part?
Yes, but it will take a lot of time.
Okay, it will take a lot of time, right? Okay, so I'll just go
So
through
you can
this.
just write the answer.
So I can directly give you answers.
Yes. Yes.
Okay, so this will give you the. Uh, just a second, I'll just remove it. Let's say whatever you got the equation. Okay, whatever equation you are getting, put the whole thing equals to 0. Okay,
Yes.
so if you do this, you will be getting x equals to a by under root, not a actually. Put it equals to r by under root. This is the point where you will be having a maximum. Okay, even if you want, you can just try put the value of x equals to r under root. So k this r divided by under root 2. Inside, if you see, r square divided by 2 plus r square, and 3 by 2 is there. So k q r under root 2, and what you are going to get from here is something like, okay, r square is there, it will become r cube outside. You are left with a, I think 3 by 2, so it will be 3 by 2 to power 3 by 2, something like this. So this will get cancelled, kq by r square, and you are left with something under root 2, and half is also there. So yeah, I think 2 times of under root, not like this, 3 by, this will be your answer, something. Okay, it will convert into this.
Yes, sir.
So just leave this. You got the value right. What is the x equals to, r is equals to this value should be the answer.
Yes.
Okay, let's move to the disk. Should I take the disk part in the session?
Like, what do you mean?
No, I'm saying like, should I teach the disk part in the session, or you can do?
I think I can do that.
Okay, so
So did we do the infinity part in the last class
wait, just a second.
or the rod?
Just a second. I'll just check. Yeah, we did actually. And this was a line chart, right? So if you see
Yes, yes.
carefully, you can just go through the PPT. I shared the PPT. You got it or not?
Yes, I got it.
Okay, look, in general, what happens now, if you see the NCRT, they have gone through the normal, directly the infinite method. Okay, how you can calculate for the infinite. Here, what I
Okay.
have done is, I instead of going directly to the infinite, I have started assuming it to be the finite one. Okay, I have considered every condition, so I have got this result. Using this
Okay.
result, whatever any kind of rod you have, for example, if someone says this is the thing, you have to figure out the electric field here. Okay, I know one thing. With respect to this, what is the angle? One angle is zero, like because charge is here itself, right? So one angle is zero itself. Another angle has some value. Okay, if both are infinite, both will become 90. If one is infinite, one become 90, and other will have some angle. Okay, so you can see we have done this case, these different cases also. So
Yes.
yeah, you can see here your theta is different, theta 2, theta 1. Semi-infinite mean to say one will get 90 degrees. So I have assumed one as 90 degree. Fully infinite, both will become 90 degrees. So you got this answer. Okay, only one case will be there in this case. If both of the angle will equal, not 90 degree, again this case will come up. Okay, so these are the things. All right. So, which special shapes you want me to discuss? Because look, there are too many shapes are there in this chapter, to, which can be discussed. Any specific shape you want to discuss
Is
in the
like
first?
any like variation in all of them, or we have to do the same thing?
Wait. Okay. Now say. I think your
Is
voice
there
was
some
bit.
kind of variation in all of those cases, or it's just we have to do the same thing?
I'm not getting your voice properly. I'm not sure what's the problem.
Give me a second. Is it better
Not yet. I feel.
now?
Yeah. Now it's fine. Now it's fine.
Yes, so I was saying that is there any variation in all of these cases, or they are the same?
Actually, they are same, but bit of the like just the integration based variations are there.
Okay.
Okay, if you
So
want, I have a sheet. I can directly provide you that. Okay, it will contain all the formula related to this. You can do the derivations if you want. If you are not able to make it, we can discuss each of them one by one. Will it work?
you should just share the sheet. I will go through it once.
Okay, so just a second, I'll be sharing it. Yeah. Okay. So I'll be sharing it within a minute here itself, the screen. Some useful results. Yes, is it? There it is. Okay, Pratham. So I'm just sharing. You can look at this. Take a look at this. I've shared it. I'm not sure. Is it visible to you or not?
Yes, it is. It is
It
visible.
might be very small, very small in the picture. I'll just increase it. Zoom it a bit. How I can do this. I hope it is downloaded now. Does it increase the value of picture? not getting option to increase its size. Okay, how to increase its size? Something, some option should be there. No. Okay, got the option. I think now it may be visible. Hello, Pratham. Now is it visible or not?
Yes, sir.
Okay, so you can go through one by one each. So if you see carefully, let's check this one. Okay, not this is 2 point charge. Remove it. Okay, if you see carefully, this one is the finite rod wala case. Okay, we already discussed these two formula. Okay, if it becomes a semi-infinite, you will be getting something these kind of formula. Clear?
Yes, sir.
Right. One more thing, if you see carefully, all these formula contain density wala portion, and I think we have discussed the value in the form of charges. So you can convert these into the charges also. Okay, no, we have taken density itself. That's fine. That's more than enough. For some cases, we have discussed charges. So you can see this is the ring wala case, and this is the disk wala case. Okay,
Okay.
disk you can have two kind of things will be there. One is the charge disk, and this is also charge, but it is a infinite. So if you see carefully here, if the whatever I gave you in the yesterday, if you solve it, you will be getting this as a result. Okay,
Okay.
and at this point, because we are working, sometimes instead of this, it can you can also say, for example, this is the angle, right? If I say this is the angle and this is the phi, so you can also call it as what you can call the whole thing as cos phi. Understood?
Yes.
Okay. So basically, it is very similar to Ex equals to sigma by 2 epsilon naught 1 minus cos phi. That's it.
Okay.
You need to remember this result because we are going to use this result in Gauss law chapter for one more thing. When we will be saying that uh, flux passing through the conical section. Okay. In that case, we'll be using this result. Understood?
Yes, sir.
Okay, and again, very simple idea is there. If your r, basically the radius, when this r goes very bigger as compared to this x, in that case you can assume is this thing to be infinite sheet. Can you like you can assume that, right?
Yes,
If
yes, yes.
okay, in that case the whole thing becomes zero. You will get this result.
Okay, sir.
So that is the thing. Yeah, so these different shapes are there. After the class you can go through each of them. Okay, if you have any doubt any of them, so we will discuss the derivation of that. Okay, or else you can also try. You can see they have proper taken all the elements, so you can take the hint from this.
Okay. Okay, sir.
Okay, so yeah, this is what the thing. Mm. All right, so today I'm going to start with the electric dipole. Clear?
Yes, sir.
So what is electric dipole first? Electric dipole, by the definition, by the term, what do you understand by the electric dipole? Basically, a system, where is it? A system of two equal charges, equal and opposite, I can say, equal and opposite charges. Okay, how we are placing them are placed or separated. Let's call it separated by very small distance. Very small distance. Okay. So what this means is you have a positive charge here, you have a negative charge over here. Okay, this is if I call it as q, if I call it as minus q, and if I say the distance is how much, d. Okay, this d is very small, very small. Okay, this d is very small. So in this case, the whole thing we call as dipole system. Okay, we call it as dipole system. All right. Also, if you see carefully, what is the direction of electric field in this? Any idea in between?
Uh,
If I
Negative
make it like this,
positive charge.
positive to negative, right? Okay. Or but if I ask what is the direction of dipole moment, so the dipole moment is basically opposite of the electric field. So if I ask you what is the
Okay.
okay, so I can say this is the direction of electric field, but this is the direction of dipole moment. Clear?
Yes, sir.
And a dipole moment is given by what? Is given by product of charge and distance. Product of charge and distance between them. Okay, charge and distance between them. So what I can say that my dipole moment. Why am I right? Let's refresh it. I hope it should work now. Yeah, it is working. Okay. So where we were, I think did I write anything? No. Okay. So what is dipole moment? It can be given by what is it? Charge into product. Let's not write it into the vector form is equals to q. What is the charge? We have to put the magnitude. So this into distance. Is that clear?
Okay. Yes, yes.
But one more thing. In general, I'm just telling the book's term. Okay. As per the book's term, in general, d is very small. Okay, very small. So to do the so for the ease of operations, ease of calculations, we can say that d is equals to 2 times of L. Understood? What I meant is because the distance is very small. Okay, this distance is very small. So when we will be doing some operation on it, instead of doing the d by 2 thing, what I can say this: if d becomes 2L, if my d becomes 2L, I will left like I will not be having to do this operation. I can directly put L and L. Is that clear?
Yes.
So I can replace the whole d with 2 of L. Okay. So where is if this is my distance d, I can call it as 2L. Okay, and this portion from here to here is how much? This is L. I hope it makes sense for now. So
Yes.
2L. Is that clear?
Yes, yes.
Okay. All right. One more thing, if I have to keep it into the vector form, so it will become P equals to what can be this?
I
What
have
it
no
can?
idea.
Uh, you don't remember? Just put the Q into L vector. Okay. Basically, your
Acha.
what happened?
No, no, it's fine.
Okay, I forgot. It should be 2L, okay? Because we did 2QL. Clear?
Yes.
Understood?
Yes,
And
yes.
just notice one thing. The direction of dipole moment is opposite to the moment is opposite to the direction of electric field between charges. Electric field between charges.
Yes,
Clear?
sir.
These things you have to keep in mind. All right. This is an important part we discussed. That's it. Okay. If I ask you what is the SI unit of it,
Charge length.
SI units. So it will be basically coulomb meter, not per meter. It's just meter. Okay. So this is what we discussed about the electric field, like dipole moment. Okay, and dipole is basically the combination of two charges placed in a very small distance. That is your dipole. Basically, why we are saying dipole? Di refers for the two pole, mean to say it is positive, it is negative. So we have two different things. So we are calling it as a dipole. Okay, it is combination. That's why we are calling it as dipole. Okay, that's the thing. Now we can move
Okay.
to the calculation based on. If you know that you have a dipole placed over here, positive and negative, so it must be having some electric field. You know there's an electric field in between. That's fine. You can even calculate that using further method. But we are interested to discuss the direction of electric field due to the dipole at this point, at the very center. We call it as equatorial. Okay, equatorial length. Maybe here, maybe here. After this, we will be having a random direction. Okay, these 3 to 4 things we are going to do. Clear? So the topic will go as electric field due to electric dipole. Okay. So first we will be calculating the electric field due to dipole on the axis. Clear?
Yes.
Hello Pratham, are you there?
Yes. 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 Sir.
Okay. So what we are going to do is we will try to calculate the electric field due to dipole at some points.
Okay.
Okay. So how we can do that? Any idea?
Is
Okay.
it this?
Yeah. So first we'll be having three things. First at axis, like at axial line, not axis. It will be at axial line.
Okay.
Okay. What it meant by axial line? I'll just refer. One charge is this positive, another charge is negative. Okay. This is a dipole. This is the line joining both of them. Okay, so axial mean to say you have to calculate. You can be you need like you need to calculate electric field on either this side, either this side. Okay, this is the axial line. Clear?
Okay.
If
Yes.
it says equatorial, go the very center at the perpendicular.
Okay.
Equatorial, axial. Clear?
Yes.
So I can remove it. E electric field on axial line. So a very simple idea is let's take the positive charge over here and the negative charge over here. Okay, this is the center point, so I can say the distance to be L. Distance to be L because we are taking the whole distances to L. Is
Yes.
that clear? Okay. So I
Yes.
have a positive charge which is placed at a distance x. Okay. Now why we took this LL, you will get the idea. Just assume if I told you if we don't have the concept of this L, and if I ask say that you have a charge plate at a distance x, so how you will assume? Will you say that it is with respect to like it is at distance x from here? Will you say it is from here? Because if I say it is at distance x from here, you can assume that this is the condition, but it may not be the condition. Condition may be like this. Understood my point?
Okay. Yes.
Okay. So when we say that the point is at distance x, it means to say it is saying that the point is at the distance x from the center of the dipole. Clear? So this is your distance x. All right. So if I ask you what is the electric field here, so you know due to this positive charge, the electric field will be E positive. Understood? And due to this negative, it will be this direction, E minus q. Make sense?
Yes.
Okay. So I have to calculate the net effect. So what I can do is I'll be getting E net. How you can calculate E net? Just add both of them. If I'm putting magnitude thing, I can add both of them. If I'm going vector, so I just have to go through the vector forms. Okay. So I am going in the vector form, then it's better. So what is the electric field due to the negative one? So just put the values. K, okay, it is minus q, so I can put that minus q also, divided by what is the distance now? What is the distance right now?
X.
It is not x. Due to this, how much is the distance? It is x minus this L portion.
Yes.
X minus L portion. Okay. Plus what? EQ. What is EQ? KQ divided by, if you see this is the x plus L, here you have
Yes.
to add.
Yes. Got
So
it.
what you got in final as a result? One more thing, we have to go with the direction also. What is the direction of this electric field over here? So I can say it is, let's say this is x, okay, and this is the minus x. So we can call it as I or j also. So this direction is I, this direction is what is it? Minus I basically. So let's keep all these things aside. Can we do this in anyhow?
I
Okay,
think
yeah.
yes.
So basically this will be your thing. We just have to solve this portion. So kq minus kq, what is it, divided by x plus L square, x minus L square. Okay, by seeing the value you might have get to know that this is lesser than as compared to this,
Yes.
right? Okay, so overall answer is going to be negative.
Yeah.
Okay, and we can easily assume, like, if the overall answer is negative, it means your charge is closer to the negative, and we can see here my charge, here my this point is closer to the negative side. If I would have been at this side, the answer would have been positive. Understood this part?
Yes.
Okay, so it, like, even if you have doubt now, if we had taken this side, will it will it make any difference in my formula? It won't make any difference, because this negative sign or positive sign at the end of the day will do its own work. Okay, you
Okay.
don't have to care about that. So yeah, we just have to solve it out. I can take the q, kq as a common. You will left it with it, square minus x plus L of square, and hereby you will be having x square minus L square, the square of it. Okay, and whatever the
Okay.
let's remove the direction basically right now. Okay, so you have kq. If you solve this portion, what you are going to get? If you solve this thing, this and this portion, you will be
2x
getting minus 4 times of x divided by x square.
minus.
Yeah. Why? I'll just, what is it? A minus b ka whole square plus a plus b ka whole square. Okay. Difference, basically difference of both thing comes out
Acha.
as 4ab. Okay.
Got it.
Like, it depends, if this is first, so it will be your positive. If it is negative, even if
Yes.
you can
Yes.
open it, a square plus b square minus 2a minus a square minus b square minus 2ab. God cancel. Understood?
Yes, sir.
Let's see. So this was the thing. Okay, what you can see here is, just take all these inside. Let's put the magnitude, okay, because the negative side is there. I want to remove it for now. So k q 4 x L divided by what is it? X square minus L square of square. Okay, if you see, can I rewrite the same thing into 2 into 2k q L x divided by what is it? X square minus L square square. Can I write this?
Yes.
Okay, let's do one more thing. Remove this k also and rewrite the same thing as QLKX. Clear?
Okay.
Does it seems like the whatever we have studied, anything we have studied similar to this?
The dipole.
The dipole, right? So can I say it is nothing but the dipole? So what is your electric field comes out as? It is 2 dipole moment, the value, into x of k divided by what is it? X square minus L square of square. Is clear?
Yes.
Okay. Um, all right, that's fine. So it's up to you. You can rewrite the same thing as 1 by 4 pi epsilon naught. I just open this k, and here you will be having 2 px divided by x square minus L square. Clear?
Yes.
Now just check it again. What is this x? What is this L? L is the distance between center to the dipole, right? So if I say that L is very, very, very less than x, in that case, what your formula goes like, it will become 2px divided by 4 pi epsilon naught. Look, when your L is very less than, you can just rewrite the same thing, right? So it will become x square 4 2p divided by 4 pi epsilon naught x2. This is what your answer will look like in this situation.
Okay, sir.
Clear?
Yes.
Uh, so, yeah, let's go back to the discussion session. Okay, let's talk about the direction also. If you see here, what is the direction of electric field? This is the direction of electric field. This is the direction of electric field, is it?
Yes.
Okay, and because if you see, my answer is the final answer comes out in the dipole, in the form of dipole. So what we will do, we will compare it with the direction of dipole moment. So what is the direction of dipole moment? It is from negative to positive, right? If you could remember.
Yes.
P. Okay. Okay. What is my net direction of electric field? You know, the negative will negative is greater. So I can say, isn't it the electric field at this point is in the direction of this?
So can you repeat?
What I'm saying is, I have calculated electric field at this point. You know, the charge is like the magnitude of the charge is same, right? So it is
Yes.
very like clear that the negative will dominate. Like the
Yes.
electric field due to the negative will dominate as compared to the
Yes. Yes.
positive. So the net electric field direction should be this.
Yes.
So can I say, is it similar to the direction of this dipole moment?
Yes.
So what we will do, it to make it in the vector form, I can introduce just one thing. Put this 2p, just put the vector. Okay. Why we were comparing, if it was the case that electric field, like the dipole moment was in this direction, okay, like dipole moment was in this direction, and electric field is in your, like whatever calculated was in this direction. So we could have done is negative to make it this direction. Clear?
Okay.
Understood this part or not?
Yes, sir.
Okay. So basically, we just have to give some direction. Okay. Instead of taking some other parameter, we are comparing it with this itself. Okay. So what is the real
Okay.
formula? You have to remember real formula also. 4 pi epsilon naught x square minus L square. Yes. If the question says it is a short dipole, when we say short dipole, mean to say we assume this condition. Like we assume this condition. Okay, that your L is going to be very, very small. So we don't have to take care of these x square minus this and the other parameters. Is that clear?
Okay.
I hope
Yes.
for short dipole, you can write for short dipole. So this is what your electric field due to the dipole on the axial line looks like.
Okay.
Okay, let's do the same thing in the equatorial position. Okay. Electric field on equatorial. Okay. So what is equatorial basically? Equatorial is the center point. I can say if it is positive charge, it is negative charge. If I go like this, some distance, this and this. Okay, these are your charges. I can say it is a Q, it is a minus Q. Clear?
Okay.
This is the line joining to this. So I know this is my L. So what is your equatorial? It will be the perpendicular line
Okay.
bisecting the. line joining your dipole.
Hmm.
Equatorial axis, or you can say 90 degrees. So you may have to calculate electric field at any point here. Let's say this is the point, right? So I can join it easily, this
Okay.
and this. One more thing is very known, that there is symmetry both sides. Okay, so I can do is, let's calculate electric field. Electric field due to this, it will be in this direction. E positive Q. Due to this, it will be in this direction, towards right. E negative Q. Okay. Also, if I say this is angle theta, this will also be theta. Is it?
Yes.
Okay. Well, now, if this is theta, this can be okay. Let's not call it theta or something. Let's say this is theta. Okay.
Okay.
Remove it. This is theta. If this is theta, what angle will it be?
90 minus theta.
It will be 90 minus theta. Okay. It will again, what it will become? It will also become theta, because the whole thing.
Yes, yes.
Okay. Or I can directly say that this is also theta. Can I say this?
Uh,
Just check out the angle, and check it once. This is also your theta. This thing, this and this, both are theta angle. Look, you can see the symmetry part. Due to the symmetry, I am saying.
yes.
Okay, all right.
Yes,
So
yes.
this will become e positive q cos theta. This will also become e negative q cos theta. And here you will be
Okay.
having two times of e. Let's say, uh, okay, e positive q sin theta plus e minus q sin theta, if you see carefully. Now, I know one thing. The charge is same, the distance is same. Like this distance, this distance is also same. Everything is same. Just the direction will be different. So can I say the magnitude part is same?
Yes.
If this magnitude is same, this cost is same. So can I say the this component will get cancelled?
Yes.
So what I'll be left with? I'll left with this, and also this and this. The magnitude is same. So can I say it is net equals to 2 EQ sine theta?
Yes.
So what is my net electric field? It is nothing but 2 E sine theta. And what is that E sine theta? 2 times of K, whatever the Q, sine theta. I have not put the value yet. We'll put it with a minute. Okay, divided by the distance square, that is your R square. Okay, you know one thing, we take the distance as this. Okay, we call this as the distance, how much distance I am. If I say this is x, can I say this is x?
Okay. Yes.
Okay, this is L. So what is this distance? Because the actual distance between charge and the point is this, right? So I can say this is L square plus x square under root.
Yes.
So isn't it become L square plus x square?
Yes.
Okay, this is what I got. Further, what I can do, I have to get the sine theta also. What is sine theta? Here the sine theta is nothing but perpendicular upon hypotenuse. So this sine theta can be rewritten as 2kq L divided by L square plus x square. Okay, and what is this hypotenuse?
Power
Hypotenuse, this thing, right? So it will
3 by
become
2.
3 by 2. Clear?
Yes.
Remove it. So this is what your final formula looks like. Understood?
Yes.
Okay, if you see, I can rearrange it and I will get k 2ql divided by L square plus x square, 3 by 2. Okay, and if I have to write this in the vector form, so what I can do is put the electric field. Okay, what it is, let's not make it vector right now. E vector, again not vector. E equals to 2p divided by L square plus x square, 3 by 2. Make sense?
Yes.
It should not be 2, it should be k. Clear?
Okay.
Now just let's talk about the direction. What is the direction over here? This is the direction of P, right?
Yes.
And what is the direction of electric field? This. So you can see here the direction is opposite. So what I can do is I can simply put this and negative. Clear? Basically, my electric field is in the opposite direction. Basically, opposite. This is the direction of P. My electric field is in the opposite direction of this P. Is that clear?
Okay.
So
Yes.
here we
Yes.
got this. Again, this very similar operation you can do is you can say if my x is what very greater than L, so your electric field will become nothing but negative of Kp divided by uh, x square, x cube basically. You can see the formula is same.
Yes.
What's the difference? It
The
is
two.
just the half. If I talk about the magnitude,
Yes.
it is just the half of the line. You can see in the line it was twice. It was nearly
It was
twice. 2p higher. Okay. Let's make this in the form of k so it will be better to see. 2 p 2 kp divided by x square. Clear? So you can see that
yes.
is 2 kp. This is this. Just a half. And what about the direction? There, the direction of electric field will be the direction of dipole moment. Clear?
Clear.
Okay. And here, if you see, yeah, this is the whatever it is. This is the thing condition we have. It is opposite to the dipole direction of electric field. Any doubt till now?
Clear. No. No. No.
Yeah, so that's all about the today's lecture. It's 10:40 of it. Okay. So yeah. So I will suggest you to go through this pay part. Okay. Maybe if you want, you can try to solve by using some derivation method. If you can do, it will be a better option.
Okay.
And also, don't forget to solve problems. At least try to solve at least 3 to 4 problems on each topic. Okay,
Okay.
on the different variations.
I'll do Singage.
Okay, yeah, you can do the singles also. And in this, let me check if something more can happen. Okay, in this, one more case is left. Like if you see, this is a very general case, right? Either it, whatever we have solved, either it is this or either it is this. Tomorrow, just within a 5 to 10 minutes, we'll discuss what if you have a random angle theta. You have given at very random angle theta. What is the electric field at this point at x at theta? Okay, this theta can be this, this. It can be anything. Okay.
Okay.
So this we will cover in the next session.
Okay.
Yeah.
Yes, sir.
Okay. So yeah, that's all for the day. You can end the session.
Okay.
Goodbye.